Hey everyone, this is Samarth. Welcome back to the playlist in which we are creating a node app with backend in Ktor. In this video, we will set up our room database and retrofit instance for our Android app. So let's start this video. So in last video, we have seen the starter project and we have set up the dependency injection, and also we have created this session manager class for managing the JWT token in data store. In this video, we have to set up room database and retrofit instance. So as I have said, we will be using MVVM architecture in our project. If you don't know what MVVM is, its full form is model view model, and what it do is it just separate the different layers and help us to maintain our app easily, and it increase the readability and scalability of the code which we have implemented. So basically, first of all, there is a data layer, and this data layer can be divided into two parts. One is local data source and the other one is remote data source. In our project, we will be using both the data sources, and to connect these two data sources, we need some interface, and for that repository is there. And above that, there is a view model which will be connected to repository, and it don't cares about two different data sources because repository has combined these two data sources, and it is responsibility of repository to manage these two data sources. And in view model, we have to write all the computation or all the business logic which is not related to UI part, and above that there is a UI layer which is just XML in our project. So this is all about MVVM architecture, and for local data source we will be using room database, and for remote data source we have our own API which we have created in Ktor. So to do that, we have to create a new data package in this Ktor node app, and name it data. Now in this data package we will create two packages. One is local and another one is remote, for differentiating between local and remote data. Now first of all, we will set up room database. So to set up room database, we have to create one more package in this local package named models, and in this models package we have to create a data class named local node. Why we are creating it as a local node but not simply a node? Because in our local node there will be some more properties than the remote node. You will understand it later, but now first of all let's do it. Now here we have to add some properties. The first one is node title, which is a nullable string, and by default it is null. And then description, and take care, you will be writing here where, not val, because we will be making it as an entity in our room database, and to make an entity in room database we have to specify where here, not val. So after that, the next property is date, which is long, and by default it will be system dot current time in millis. And then the next property is connected, which is a boolean, and by default it is false. So connected means if the node is connected to the server or not. And the next property is locally deleted. It is also boolean, and by default it is false. And it means that if the node is locally deleted but it is not deleted from the server, because for example, if our internet connection is off and we will delete the node, then it will not be deleted from the server. So we have to take a look that when the internet connection will be on, and then we have to delete the node from the server also. And after that, the next property is node ID, which is a string, and by default it is UUID dot random UUID, and then toString. Basically it will just generate a random string. We have to specify here the primary key, and auto generate should be false because we don't want room database to generate key automatically. And here we have to write one more annotation, that is entity, because it will be entity in room database. Now the next thing is we have to create a DAO package in a local package, and let's make a DAO. And in this DAO package we have to create a interface which is not DAO, select interface. And here we have to write some functions to perform some operations on room database. So the first function is insert node. It will be a suspend function because we are doing input output operations, so it will be suspend function, and the function is insert node, and it will take node as a parameter, and it will be local node. Then we have to write annotation, that is insert, and here we have to write the conflict strategy, that is on conflict. We want to replace the node when any conflict occurs, so the conflict strategy is replace. And the next function is to get all the nodes ordered by date. We can return live data also, but we will use coroutine flows. So write flow and select this coroutines flow, and here we have to write the data type, which is list of local node, and here we have to write a query, select star from local node where locally deleted is false and it should be ordered by date, and the order should be descending. Now the next function is to delete the node. So let's create a new suspend function to delete node. One more thing is it should not be suspend function. It is just a normal function because we are using flows here, and to get the live data we don't want it to be suspend function. Now here we have to accept a parameter which is a node id and which is of type string, and here we have to write a query, delete from local node where node id is equals to this node id. Now the next function is to delete the node locally, so and it will contain node id, and basically we don't want to delete the node from our database. We just want to update the locally deleted variable of our node. So here we have to write a query which is update local node and set locally deleted to 1. It means we have set the locally deleted variable to true. We have to update that node where the node id is equals to this node id. Now the next function is to get all the nodes which are not currently pushed to the server. So let's write a function to get all local nodes, and it will return a list of local nodes, and here we have to write a query to select star from local node where connected is 0, and one more and there is one more function to get all the locally deleted nodes, and it is list of local nodes, and here we have to write a query. Let's copy it and paste it here and set locally deleted is equals to 1. That's all for this node DAO. So in this local package we have to create a new class which is node database, and it should be abstract class, and it should be extended from room database, and it will contain an abstract function get node DAO, and here we have to write annotation which is database. Here we have to write some parameters, which is the first one is entities, and it means we have to list all the tables we have created in our node database, and currently we have only created one table, so we have to write local node double colon class, and yeah, it is an array. So the next variable is a version of our database. It is a first version, and then we have to write export schema is equals to false. Now let's come to our dependency injection package, and in this app module we have to write a function to provide our node database. Let's write a function provide node database, and it will contain a parameter named context and extended with the annotation which is application context, and here we have to write context, and then it will return a node database. So let's create our node database quickly. So to create it, call this room dot database builder, and here we have to pass the context, and then the class which is extended from room database which is node database double colon class dot java, and then the name of the database which is notedb in our case, or you can write anything here, and then we have to call dot build function, and we forgot to add these two annotations here. Just copy it and paste it here. We have to create one more function here which is to provide the node DAO. So let's create a function provide node DAO, and it will take notedb in parameters, and it will return node DAO. So call notedb dot get node DAO, and here we have to write that annotations. Basically it will get this node database from our this provide function. So that is it for our remote database, and now let's work for our retrofit. So first of all, in this remote package we have to create one more package which is models, And in this models package we have to create a new class which is remote node. It is a data class, and here we have to write some properties which is node title, and it is a nullable string, and then we have to write description, which is also nullable string, and then the date, which is a long, and then the node id, which is a string. All the properties of this remote node should match with the node data class which we have created in server. Now in this models package we have to create one more data class which is simple response, and it will contain two properties, which one is success, which is boolean, one is message, which is a string. And also we have to create one more data class which is user, and here we have to write the name as a nullable string, and by default it is null. And then the next property is email, which is string, and then password, which is also a string. So these are our model classes, and now in this remote package we have to create a interface which is not API, which will contain all the functions to make network calls. And here we have to write all the functions to make network calls. And for that I have created a little website, as you can see here, where all the information of our all the routes is present. So first of all, in this utils package, in this constant class, we have to write one constant which is base URL. I just have to copy it from here and paste it here. Obviously you have to write your own base URL here, because I will stop the Heroku project and it will not work for you. And then we have to write one more constant which is API version. Right now it is v1. You can update it later if you want. Now our first function is to create account, as you can see here. So let's create a suspend function, create account, and it will accept a body which is here, as you can see, which is a user. So body is user, and it will be a post function. As you can see, the request type is post. So let's write it as a post function. The route is API version slash users slash register, and it will contain headers, which is content type is application slash JSON, and it will return a simple response. So the next function is copy it and paste it here and change it to login, and here it will also accept a user, and it will return simple response, and the URL is user slash login. Now let's create functions for our nodes, and the first function is to create the node. In body we are passing a node, so body is node, and it is a remote node. And for header and post request we will just copy it and paste it here. Then we have to update the route, which is nodes slash create, and then it is authenticated route, so we have to pass JWT token in header. So let's create a header which is authorization, and here we have to pass token which is of type string, and then comma, and again it will return a simple response. And then we have to just copy this function and paste here. Here we have to write get all the nodes to get all the nodes from the server, and here we have to update the route, and it is a get route, and we don't need to pass any body, and then it will return a list of remote nodes. Now just copy this create node function and paste here 2 times. So the first one is for update the node, and the second one is for delete the node. In update node we have to write the update here, and then everything is same. And then in delete function we have to pass the query parameter instead of this body. So let's pass query parameter, which is id, and it is equals to node id, and it is a string, and it will again return a simple response. And here we have to update the route, which is delete route, and update it to delete, because here you can see the request type is delete. So that's all for our node API. Now we have to create a retrofit instance. So let's create it. So open your app module and And here we have to provide retrofit instance. Basically we have to provide that Node API class. So just write fun provide Node API, and it will return Node API. Let's first annotate it with singleton. Now first of all we have to create a variable that is HTTP logging interceptor, and which is equals to HTTP logging interceptor, and then we have to set a level which is level.body to get the body level logs when we are doing network requests. And then we have to make a client which is equal to OKHTTP client dot builder, and then we have to add interceptor which is HTTP logging interceptor, and then we have to build it. And now we have to return retrofit instance. So make retrofit dot builder, and here we have to set base URL which is base URL which we have specified in our constants file, and then we have to set client which is this client we have created above it, and then we have to specify the converter factory which is our JSON converter factory dot create, and then we have to call build. After we have built the retrofit instance, we have to create Node API. So let's create Node API class.java, and it will simply return Node API. So that's all for this video. In this video we have set up room database and we have set up the retrofit instance, and in next video we will set up our navigation. So stay tuned and thank you for watching this video.